This is number 3 on your study guide for your rational expressions and equations test. You'll notice on this particular expression that it is just one fraction or rational expression, which means you're going to simplify. Okay, and what that means is you're probably going to factor. So if you look at the numerator, 6k squared minus 11k plus 4, that is a trinomial, and you'll notice there are no greatest common factors. At first I thought there might be a 2 as a greatest common factor, but there's not, because 11 on the 11k is not divisible by 2, which means that I'm going to have to factor this some other way. Now, I use factoring by grouping, but it's essentially the same thing. I ask myself, remember, you multiply those two, what are the factors of 24? And that's a positive 24. So factors of that add to 11. Now, I don't happen to know that right away, so I just do a factor list and start with 1. 1 times 24. Through addition or subtraction, there's no way that I could get an 11 from those two numbers. So 2 times 12, I'm getting close, but no, there's no way that I can get an 11 by adding those or subtracting those. So 3 times 3 into 24 is 8. 3 times 8, I think, yep, I believe that's probably it, but I'm going to go ahead and do 4 times 6. 5 won't work, and 6 times 4. As soon as they reverse like that, you know that everything above is the full list of all your factors. And so, yeah, 3 and 8 are going to be the factors here. Now, I do factor by grouping, which means that I just rewrite this expression, 6k squared, and then plus 4. But I rewrite the center, one term, as a combination of two terms, and I've got to do a 3 and an 8. That's a negative, keep in mind, and let me show you, a negative 11k right there. So I'm going to rewrite negative 11k as negative 3k minus 8k. Sorry. Negative 3k minus 8k is the same as negative 11k. So I just rewrote the first numerator in a different way. The reason I did that is so that I could factor out a greatest common factor. So I look at the first two and decide what is the greatest common factor of 6k squared and 3k. And I believe I can pull a 3 and a k out of those. And if I do, I end up with a 2k and minus 1. Okay, I do the same thing here. I'm going to pull a negative, because there's a negative there, you've got to pull it, just a negative 4 out of both 8k and 4. So if I pull a negative 4 from a negative 8k, that gives me a positive 2k. And then because it was negative, I've got to say minus 1 by division. Okay, and I'm still working on, I'll go back and catch the denominator up in just a second. I'm still just on the numerator here. Notice that I have a common factor now. It's that whole thing, which you can pull out and sit in front. And so what you have here is 2k minus 1. If you took that factor from both of those, you would end up with a 3k minus 4. And now my numerator is factored. Okay, so I'm going to leave that there for now because I'm done as far as I can go there, and I'm going to go back here to 9k squared minus 16. Now I want to tell you that this same process that I just showed you, it would work. You just have to remember that the middle term is actually 0k. But what I'm noticing here is that this is a special case. Because 9k squared, I'm going to keep writing perfect squares. And let me be even more, it's the difference of two perfect squares. Because 9k squared is the same as 3k times 3k, that means 9k squared is a perfect square. Similarly, 16 is 4 times 4. That's because 16 is a perfect square as well. What that means is when you've got the difference of two perfect squares, what you end up with is a sum and a difference problem. Now both of them end up with 3k and 4, 3k and 4, but one gets a plus, one gets a minus. If you want to multiply that out, you can, but it ends up being 3k plus 4 times 3k minus 4. Because in algebra, you never write an untrue statement, I am continuing to just pull this through because I'm finished with factoring, okay, until I've got the numerator fully factored and the denominator fully factored. All I'm looking for is a version of 1 that will allow me to cancel. And remember, you can't cancel out of addition or subtraction. You can cancel all of addition and subtraction, meaning that entire binomial there and that entire binomial there, those can cancel. And in the end, you're left with 2k minus 1 over 3k plus 4. And remember, parentheses never hurt. If you left them off right there, it would be okay, but I say when in doubt, just put them on, because it helps you to remember you can't cancel parts of these binomials. It's all or nothing, okay? Which means that is in its simplest possible form, and there's your answer.